Okay, let's do this. Right. The first question here says that I have a penny, 3.94 grams. It's going to react with nitric acid, which is 1.5 molar. The question is, what volume of the nitric acid is needed to react with that penny? So, what are we going to do? We're going to do a mass calculation. We're going to determine the mass of nitric acid. Then we're going to determine what volume of that concentration is going to contain that mass. Make sense? Yes or no? What's the mass of 1.5 moles of nitric acid? What's the mass of 1.5 moles of nitric acid? Because doesn't that say it's 1.5 moles per 1,000 milliliters? What's the mass of 1.5 moles of nitric acid? You remember? 63 times 1.5, 94.5. Okay. So I know that it's 94.5 grams per 1,000 milliliters. Right? So when I come up with the mass that is, then I can determine what volume I need, correct? All right, now, I'm comparing copper with nitric acid. What's the mass of 3 moles of copper? Everyone, shut your computers now. Thank you. Everyone. Mr. Joe? Now. What is it? 192 grams. What's the mass of 8 moles of nitric acid? I said shut your computer. I don't like to have to repeat myself more than 3 or 4 times. What is it? 504. Okay, good. Now I want to set up a proportional relationship using that constant ratio. So I'll work right here. So it says 3 copper over 8 nitric acid equals 192 over 504 equals 3.94 over x. X is going to equal what? 10.3 grams. Right? 10.3 grams. Do you get that? Makes a little bit more sense now? Okay? 10.3 grams. All right. So, I know that I have 94.5 grams per 1,000 milliliters. What volume contains 3.94? I'm sorry, 10.3 grams. So that's going to equal 10.3 grams over X. So what volume is it going to be? 10.3 times 1,000 divided by 94.5. 109 milliliters, correct? So it's going to be 109. Let's use green. Shall we use green? So it'll be X equals 109 milliliters. Green is not the best to use in video. Can you see that? Did that come out?
Yeah.
Yes? Comes out?
Yeah.
We'll make it a little red too. Okay. 109 milliliters, correct? All right, the next one. This one says, I'll read it to you. It says a 250 milliliter sample of sodium sulfate is reacted with excess barium chloride. If 5.28 grams of barium sulfate is precipitated, what is the molarity of the sodium sulfate solution? So I have 250 milliliters of this. I have excess barium chloride, and I'm going to produce, that upside down arrow means precipitate, I'm going to produce 5.28 grams. So I'm going to compare this with this, okay? Take out your calculators and help me out here. 1 mole of sodium sulfate. That's 23 and 23 is 46. 46 plus 32 plus 64. 4 times 16. So it's 64. 64. $32, 46. What do we got? 142. Is that correct?
Yep.
How about this over here? 137 plus 32 plus 64. What do we got? 333? 233. Right? All right, good. Now, let's set up a ratio. So I'm going to have sodium sulfate, 1 mole, barium sulfate, equals 142 over 233 equals 5.28. Let's actually put the name of the particle. I want to know the mass of this over, right? Are you all right with that? Let's make sure it's on the screen. Right, let's go up a little bit. Is that on now?
Yeah.
Right, that looks good. So what's that going to be? So what's the mass of that? 142 times 5.28 divided by 233. What do we got?
3.22.
What is it?
3.22.
3.2. Is that right? Yes? All right, now. So I'm going to put 3.2 grams in this. Right? What's the molarity of that? What's the molarity of that? How many moles? So in other words, can I write right here? Does that come on the? Does that come on the? All right. So I can't do all of that. How's that? Does that all come on? Does that come on? Can you see the right line?
No.
Okay. So let's move it over then. We'll just move it over. We'll move the whole thing over a little bit. How's that? Good. All right, now. So, 3.2 grams in, how many liters is that? 0.25 liters, 0.25, right? So it's going to be 3.2 over 0.25 liters, right? I want to make that equivalent. What do I do? What do I divide that by? 142, correct? Isn't that correct? Alex, you with me on that? Are you sure? Cool. So 3.2 over 142, that's grams. That's gram molecular weight, and that's 0.25. So Right? Now, so that should be the molarity, correct? Yes or no? Should be. All right, so what is 3.2 divided by 142? Give me a number. What is it?
0.023.
0.023. Okay. So it's going to be 0.023 moles over 0.25 liters. Correct? Yes? So what is it? Convert that to molarity. Convert it to, we'll go right here. So 0.023 moles over 0.25 liters equals X over 1. What's the answer?
0.0.
What is it? 0.09. Is that correct? Yes? Okay. So the answer is 0.09 molar. Is the answer in the back of the book? I love it when the answer is correct. I don't care how many years I do this. I've been doing this my entire adult life. And I'm only 32 years old. Oh, you think that's funny? Really good. Laugh it up. I love it. I love it. You think I'd like, it would be just like, not a big deal, but I love it getting the right answer. Yes, easy? So let's make sure that's all on. You can meditate on that. I think the whole thing is on. So you can meditate on that, okay? I'll put these on. I'll put these on the web. It's actually the only one you need, right? So there's 2 problems on there. So we're actually quite finished. Yes? Alex, didn't you go out the last time I was finishing a video? Is this like your idea of an exit? I understand. That's fair enough. Excellent. Excellent. Okay. We're off.